Welcome to this video in the Mathistry unit. This is 2.3, where we are going to delve into how significant figures play a role in the calculations that you make in our chemistry class. If you haven't already done so, please make sure you have your chemistry notebook out so you can take notes on the lesson, your companion worksheet which has embedded problems in it to make your life a little easier, and of course a calculator so you can do the math without having to hurt your head or bust out your abacus. So without any further ado, let's get going. Let's dive right in. In any mathematical operation which is going to involve using numbers which we have derived from either measurement and significant figures, and no spoiler, they are all going to be derived from measurements because now this is like chemistry class and that's how we measure, one place beyond what you are sure of. Your answer that you get using those measurements in your calculation has to reflect the level of reliability and certainty or uncertainty of your least precise operation. Now, what does that mean? Well, I'll give you an analogy. We have all heard that a chain is no stronger than its weakest link, meaning that as tension is put on that chain, it's going to give out at that weak point. Well, the same with your calculations. If you have crappy measurements that go in to your calculations, then the answers that you get are going to be to that same level of crappiness. Check out this example. Let's say I want to calculate the area of this rug in centimeters squared. So I get out my measuring tool, which is my handy dandy tape measure, and I take that out and I start to go measure, and I get a length and a width. My length is 63.18 centimeters. My width is 32.78 centimeters. Boy, this is a pretty small rug. But when I calculate the area using my calculator, let's plug this in, equals, I wind up getting 2071.0404 centimeters squared. Now let's analyze this answer here. If I go check out how far out beyond the decimal this goes, to me this looks like it has some level of precision that goes out to the 10th, the 100th, the 1000th, the 10,000th place. That's a pretty doggone good measurement. But when I look at the measurements that went into it, it looks like to me these only go out to the 100th place. How can I get an answer that goes out to the 10,000th place here when they only came from numbers that were as good measurement-wise and mathematical precision-wise out to the 100th place? That is a virtual impossibility because you can't get an answer that is technically better than the measurements that went into it. And so, do not ever believe anything the calculator tells you. Now, in your math class, your math teachers probably say write down whatever the calculator has, and that's a legitimate number. But in chemistry land, that is not the case. So chemistry land differs a great deal from math land. In chemistry land, and here is the major rule when reporting your answers in science, your answer can only be as good as the numbers that went into the calculator and the operation. And so to help you with this, chemistry teachers and physics teachers and scientists alike all use calculation rules of significant figures. So we're going to bang that out now. Let's start off by talking about multiplication and division. In order to illustrate some points here, we're going to do some easy problems. Why don't you all pick up your calculator, put it gently in your left hand, and let's now calculate. Let's say I want to multiply 3.6 times 653. So let's put it in the calculator. And I get an answer, which is 23.50.8. That's my calculated answer, or what we're going to refer to as our raw answer. It's uncooked at this very moment. And so let's now apply the rules of significant figures to multiplication and division, because these rules are going to be a little different than addition and subtraction. I find this is the easier rule, so I throw it at you guys first. The multiplication and division rule looks like this. Your answer in multiplication and division should have the same number of significant figures as your measurement with the fewest sig figs. So what does that mean? Well, since I got an answer out of the calculator that was 2350.8, that has 5 significant figures that are in it. So 5 really reliable numbers. When I look at the numbers that went into it, 3.6 has 2 significant figures. 653 has 3 significant figures. So my answer now has to get rounded to the least number of significant figures of the numbers that went into my mathematical calculation. In this case, it's 2, so I go here and I apply my rules of rounding. I find my second significant figure, which in this case would be the 3 that's there. So I take that 3 and I look to the right of it. I see what the number is. It's a 5, so that means I'm going to take this number and I'm going to make it more. That gives me 24, and then I have to replace those significant figures with zeros to retain the magnitude of the original number I started with. So my final answer is 2400 to 2 significant figures. What's nice about this is that's the multiplication rule, but it is also the division rule as well. So I will save you the work. If you were to take those same two numbers and do the division, and we would get an answer that goes way, way, way out with many significant figures, but we only can have 2 because the number of significant figures that went in are 2 here and 3 here. And we can only answer to the least number of significant figures in multiplication and division. So my answer becomes 0.0055. So in order for you to get really good at this and apply the multiplication and division rule, please complete these calculations and round to the proper number of significant figures. The calculations are all on your companion worksheet. So pause the video now, bang those out, and then unpause the video for the answers. All right, if you did that correctly, I'm giving you here the calculator answer that is in blue and my sig figged answer that is in green. So check those out, make notes if you have any questions, and of course we could talk about it during the burning questions segment tomorrow. So I'm going to finish off multiplication and division by presenting to you with 2 special cases that you may see which might prove a little more difficult than normal to apply rules of significant figures with calculations. Check this out. Let's say we get 10.0 times 10.0 and we want to round that to 3 significant figures. Well, if we do the mathematics in our head, we know 10 times 10 is 100. Now, this has 3 sig figs. This has 3 sig figs. My answer should now also have 3 sig figs. But wait a second, 100 is only 1 sig fig. And that would be no good here. So how can we present this with 3 significant figures? Well, one of the secrets that you can use is one of the special cases we showed from the previous video where if you take a decimal point and you put the decimal point there, what that does is it makes all these other digits significant, and instead of 1 significant figure, now gives us 3 significant figures like our answer requires. Let's say you were given these numbers and you wanted to round to 2 significant figures. Well, once again, 10 times 10 is 100, which is only 1 significant figure, right? These are trailing zeros that are here without a decimal point. How can we make this an answer that's to the correct number of sig figs while still retaining the magnitude we get? Well, let's say we wanted to put a decimal point there. Now, that one would not work here because you are technically getting a value of 3 significant figures. We need to have 2. So forget about doing it like that. The secret to that is when in doubt, turn your number into scientific notation. I want to have 100 as my answer. I could just create scientific notation that's 1.0 times 10 to the 2. Remember the rule that all the numbers that appear in your coefficient are indeed significant. So by making it 1.0 times 10 to the 2, we are actually leaving us with 2 significant figures in that coefficient, which is the desired number of sig figs that match what is required in the problem, and we keep the magnitude intact. So when in doubt, you guys can use the decimal rule or the scientific notation trick to get your answer to the required number of significant figures that you want while still retaining the magnitude of your answer that you need. Now that you guys got multiplication and division in the book, now it's time to throw at y'all addition and subtraction. And in chemistry class, we actually don't use addition and subtraction as much as we do multiplication and division, so it's actually easy to forget these rules. So, as we always say, do not be that guy and forget what you have learned. So let's dive into adding and subtracting with significant figures. We're going to treat this the same as we did multiplication, division. I'm going to throw at you a problem. Let's grab our calculators, put it gently in our left hand, and let's plug this in. So if we calculate 27.93 plus 6.4, we should get 34.33. And, of course, you're sitting at home wondering what in heaven's name I should round to. Well, this is not the multiplication and division rule. This is addition and subtraction, and it is all about the number of decimal places. So, what is the rule? Here it be. In addition and subtraction, you make sure that you round your answer to include the same number of decimal places as the measurement with the fewest. So, what I wind up doing is I actually look at these two things. This one goes out to the hundredths. This one goes out to the tenths. The fewest decimal places is this number right here, 6.4. I will actually draw a line there. And you notice that line splits these two threes. It leaves this 3 here and that 3 there. That is the 3 we should be rounding to. So that is my last significant figure. So what I want to do is now apply the rules of rounding. I see that's a 3 there. It's below 5. So that means I'm going to keep that number the same. That gives me an answer of 34.3. So it is not necessarily about the number of sig figs as much as it is the least precise measurement that we have here in terms of arithmetic precision. Make sure you have that documented in your notes. Much like multiplication and division, addition and subtraction does have a special case associated with it, and I'm going to call that the whole numbers with zeros rule. Yes, we are making up that name as we go here, but we're doing it to give you a concrete reference so you can understand how that changes what you just learned. Remember, in addition and subtraction, it was all about the decimal places. If you looked at these two numbers, you probably thought we would be going out to the ones place as the last decimal place. But when you are dealing with numbers that have zeros here, which do indeed act as placeholders showing magnitude, you have to consider what this measurement really was when it was made. In terms of this measurement, this here was probably our estimate and is our final significant figure. So when we do the math on something like that, we wind up getting 15,772.49. Because that was our last significant figure, my answer can only include significant figures up to that point. So if that's going to be our last significant figure, we then have to apply the rules of rounding, look to the 7 here, and see that this gets changed into 15,800 as the correct answer. So if some of those numbers have zeros as placeholders that are simply showing magnitude, use the same addition and subtraction rule, but find that last significant figure. In this case, the 6 was our estimate, and report your answer to that place and stick the zeros in here to keep the magnitude of the original answer. So like we did before, here are some practice problems. Take these numbers that are here and apply the addition and subtraction rule and round your answers to the proper number of significant figures. Pause the video now and then unpause when you are ready to see if you are correct. Alrighty, if you did this correctly, it's the same sort of thing. We gave you the calculator answer there and gave the significant figured answer there. Remember, if you did have any questions, you can certainly bring it up during our burning questions segment when we convene next. It has been a pleasure taking you through significant figures and calculations. We'll certainly see you on the flip side. Peace out.
That's all, folks.